Hello, student. Once again, I welcome you to our Class 10 Artificial Intelligence study material for full revision. Now, today's in this full revision course material, we are going to discuss the topic of advanced modeling concept. Now, before I start the topic, just once again, I tell you that this is the course which covers the entire syllabus of your Class 10 AI, and it is containing all the topics, their skill-based employability skill chapters. Then you have each chapter summaries there, question banks are there, and previous year papers are there. So, and the most important, the facilitator 10 AI chapters, their question answers are there, separate question banks are there, and overall, it's a complete study material which will help you to score full marks in your board exam. So let me take one topic at least today. This is from advanced modeling question answer. So in advanced modeling question answer, in this one, there are questions which are there from the advanced modeling chapter of facility. Now, the very first question is saying in which type of machine learning is data labeled with desired output. So there are four types of machine learning is there: supervised, unsupervised, supervised, reinforcement, and deep learning. So labeling is associated with supervised learning. So the correct answer is supervised learning. And you can see the answer is given with the explanation which is there. Now the next one is saying an email spam filter that learns from labeled examples is an example of. So spam filter is again, machine will come to know whether it's a spam or not, depending on the training, which words are considered to be spam. Okay. Or maybe some conditions are there. So it is also here we are already telling the system. So it is a spam. It is a supervised learning. A machine learning algorithm groups similar customer purchases into clusters uses. Now, here you see there is no, based on the pattern, we are actually doing this thing. So obviously, it cannot be supervised learning because here we are not already telling what kind of thing, but we are getting it information from the pattern which is arriving from this one. So it is obviously unsupervised learning. So clustering is basically grouping similar data without labels and unsupervised learning. An AI agent playing a game and learning from rewards and penalties is. So here it's a very common one, which is the reinforcement learning, in which this award and penalty feedback is there based on which it is working. Now, the next question is which is not true about supervised learning. Requires label data used for classification and regression, can be less efficient on large data set often used in image recognition. The answer is which is not true for supervised learning. So supervised learning obviously require label data. The two types of supervised learnings are classification and regression. Yes, it is used in image recognition also. So answer C is the can be less efficient on large data set. AI concept in general is useful because of it can work on a large data set. For small data set, you can write a simple program and you can work. But when the data set becomes large, it is difficult for a program to handle. So there actually comes the use of AI. So you can understand that this is the this type of questions are there. There are more pages into it. This and there are more types of question answers are there in this one. And then you have a type of different types of questions are there. Okay, so this is if you are going to uh, see the content of all others where all the question answers given is there. Similarly, there's a question bank given on each of the topic, which can also help you to revise your concepts. So today, as I said, we are doing the topic of uh, AI advanced concept modeling. So we are going to study through the AI advanced modeling video. Okay.
You hear about
So before
artificial
we
intelligence
start this
everywhere.
one, uh, just again, a quick reminder. So till the month of December till 31st, this is at a very less price, which is afterward will be a more price. So you can purchase this course, which containing the entire study material just for 499. Okay, 499 rupees. So this, I think, this is one complete package course which can help you and it is not here before the exam. There will be live session here in which we will do the entire revision of the entire AI syllabus. Okay, so this is also one thing. So this course material is not limited to this one, but in before exam, there will be a live session on each of the chapters which are there in this thing. So I think you will show your interest in this course. So let's start the topic of how AI actually learns or AI learning advanced modeling. Okay, so let's start this one. We can, yeah.
But have you ever stopped to wonder how it actually learns? Like, what is going on inside that digital brain? Well, that's what we're going to do today. We're going to pull back the curtain and break it all down, from the huge big picture concepts all the way down to the mechanics of a single tiny thought. I mean, it really does feel like magic, doesn't it? But here's the thing. It's not magic. Behind all these everyday things is this really fascinating process of learning. Whether it's lining up your next binge watch or keeping your inbox from overflowing with junk, AI is quietly working in the background, learning patterns. And we're about to see exactly how it pulls it off. Okay, so right at the start, AI basically takes one of two different paths. You can think of it like this. It's the difference between a machine that can only follow a super strict recipe, step by step, and one that can actually taste the ingredients and come up with its own dish. So on one hand, you've got rule-based AI. This is really straightforward. A human programmer sits down and writes a whole bunch of if this, then that rules, and the machine just follows them perfectly. Think of a simple chatbot that only gets what you're saying if you use specific keywords. It works, but it's super rigid. They can't adapt. But then you have the other side, and this is where things get really interesting, learning-based AI. Instead of being told the rules, this kind of AI figures out the rules all by itself, just by digging through tons and tons of data. This is the engine behind pretty much all the advanced AI we use today, and it's exactly what we're here to unpack.
Now, I'm sure you've heard all these terms getting thrown around. AI, ML, DL. It's easy to get them all mixed up, right? But the way they relate to each other is actually pretty simple. So let's clear that up right now.
The easiest way to think about it is like a set of those Russian nesting dolls. The biggest doll, the one that holds everything else, that's artificial intelligence. That's the whole big umbrella idea of making machines smart. Then you open it up, and inside you find machine learning. This is a specific way of doing AI, where we get machines to learn from data. And then you open that one up, and you find the smallest, but maybe the most powerful doll, deep learning. This uses structures that are actually inspired by our own brains to learn from just massive amounts of data.
All right, so let's zoom in a bit on that machine learning doll. Inside of it, there are basically three main strategies that a machine uses to learn. You can think of them as three different kinds of students. First up, you've got supervised learning. This is our student with a teacher and a very detailed answer key. The AI gets a huge data set where all the answers are already labeled. Thousands of pictures of cats that are labeled cat and dogs labeled dog. Its whole goal is to figure out the pattern so it gets the right answer every single time. Next, there's unsupervised learning. For this one, imagine I just gave you a giant box of Legos, all mixed up with zero instructions. Your job is to sort them, maybe by color, maybe by shape. You have to find the patterns yourself. That's what this AI does. It gets data with no labels and has to find the hidden structures on its own. And finally, we have reinforcement learning. This is the trial and error student. The AI learns by just trying stuff. It takes an action, and if it's a good one, it gets a reward, kind of like training a dog with treats. If it's a bad one, it gets a penalty. Over time, it learns to get more rewards.
So we've got our student, our explorer, and our competitor. But what kind of problems are they actually trying to solve? Let's look at the real-world tasks these learning styles are built for.
Okay, first up, let's talk about something called classification. And you know what's wild? It pretty much all comes down to one simple thing: drawing a line. Just look at the slide. The AI gets all this data that's already sorted into groups, the red dots and the green dots. Its entire job is to learn where to draw the perfect boundary that separates them.
You see this all the time. When your email service looks at a new message and decides, is this spam or is it not spam? That's a classification model in action. It's just taking that new piece of data and figuring out which side of the line it belongs on. It's an amazing tool for any kind of this or that question.
But what if you don't need a category? What if you need an actual specific number? Well, that's where regression comes in. So instead of drawing a line to split things into groups, a regression model learns to draw a line that best fits the trend of all the data points.
The bottom line here, regression is all about predicting a number. So when a weather app gives you tomorrow's temperature, or a real estate website estimates a house price, you can bet there's a regression model chugging away in the background to come up with that exact value.
And what about our Lego sorter, that unsupervised learner? Well, it is an absolute master at finding hidden connections. A supermarket, for example, can just dump all of its sales data into one of these models. And with no help from a human, the AI might discover a really powerful pattern. Hey, it looks like shoppers who buy bread also tend to buy butter. Finding these natural connections is what powers all those you might also like recommendations you see everywhere.
All right, we've been looking at the big picture. Now it's time to zoom way in. We're going from the what AI does to the how it does it. We are going inside the brain of deep learning. So, the engine behind deep learning is something called an artificial neural network. And the inspiration for it? Well, it's the most powerful computer we know of, our own brain. These are really complex models made up of all these interconnected nodes, or neurons, that work together to process information. But to get how this massive network works, you got to start with just one single piece. The most basic, fundamental building block of the entire thing is called a perceptron. Honestly, you can just think of it as a single artificial neuron. It's this tiny little decision maker, and it's designed to do one simple thing: take in some information and spit out a yes or a no. Okay, let's make this super practical. We're going to walk through one single thought from one of these neurons. Our little perceptron is going to answer a simple question. Based on a few facts, should I go to the park?
So here's our setup. Our neuron is considering 4 things. Do I have a jacket? Do I have an umbrella? Is it sunny right now? And what's the forecast for later? But here's the key. Not all of those factors are equally important, right? So each one of these inputs has a weight attached to it, which is just a number that represents how important it is for the final decision.
All right, let's give it some data to work with. The neuron only understands numbers, so we'll turn yes into a 1 and no into a 0. So I have a jacket, that's a 1. I don't have an umbrella, that's a 0. It is sunny right now, so that's a 1. But oh, the forecast for later is bad, so that's a 0. See, we've just translated our real-world situation into a language the neuron can process. Okay, now for the magic part, the math. The neuron takes each input, each 1 or 0, and multiplies it by its weight. So the fact that it's sunny right now is really important, so it has a high weight of 3.0. Then it adds all those numbers together. Finally, it subtracts one more number, called the bias. A good way to think of the bias is like the neuron's default mood, how likely it is to say yes before it even sees the data. When all the math is done, we get a final score of 0.5.
And boom, the final step. The rule for our neuron is super simple. If the final score is greater than 0, the answer is yes. If it's 0 or negative, the answer is no. Our score was 0.5. That's positive. So the neuron has made its decision. We're going to the park.
So think about what we just did. We watched one single artificial neuron weigh some evidence and make a logical choice. But here's the real mind-blowing thought to leave you with. If just one of these can decide whether to go to the park, what happens when you link together not one, but billions of them, all learning and firing and adjusting their weights together all at once? Well, that's modern AI. It's not just a single thought anymore. It's a whole symphony of decisions.
Okay, here we come to the end of this video. So there are videos on each of the topic, plus the summary of the chapter is there in the PDF. Okay, so once again,
You hear about artificial...
before we move, before I end this one, so this is the complete course material for class 10 AI board examination. So You can go to this link, given link, and the link is also provided in the description. So all the best for your board exam, and thank you.